Today we're going to be talking about the area of parallelograms, triangles, and rhombuses. And for all of these, I am going to be defining or deriving the formulas for these. So here we have a parallelogram. And what if I took this piece of the parallelogram? I dropped down a perpendicular, which is going to be the height of the parallelogram. I took this piece here, I cut it out, and I move it over here. So I have a perpendicular. So now I have, this was the length of one base of our parallelogram, and this was the length of the height. Since we have a right angle here and it's a parallelogram, opposite angles are equal. So therefore now I've formed a rectangle. So the area of a parallelogram happens to be the same thing as the area of a rectangle. Area is the base times the height. So when we have, if I move this piece back over, so when you're looking at this, the height is the perpendicular, and sometimes it's going to be outside, to the line that contains the base of the parallelogram. So our first example, we need to find the area of that. The area is the base times the height. Okay, so the height is the perpendicular to the base. So here's my perpendicular. The perpendicular is to segment DE, so therefore DE, 14, is the base, 6 is the height. The 9 doesn't matter. So our area, therefore, is going to be 84. I didn't give us units, so you don't have to put units squared. The triangle. Okay, so now a triangle. I have a triangle here. And now, again, I'm going to derive the formula for this. So I'm going to clone. So I have now two of the same triangles, two congruent triangles. I just cloned it. It's the same exact shape and everything. If I flip this around and I put it up there, we now have a parallelogram. Okay, what was the area of a parallelogram? Well, the area of a parallelogram was base times height. But what is this? We're just looking for a triangle. We're just looking for one of these two or half of it. So our height, again, is the perpendicular to the base. Sometimes it's going to be outside. So this length here is the base. Sometimes you're going to have this being the base, and that's going to be the height. So sometimes it's going to be inside, sometimes it's going to be outside. And remember, I derived this by looking at a triangle as if it was the two triangles, two congruent triangles, as if they were a parallelogram. And then since I'm only looking for half of that parallelogram, our area is 1/2 base times height. So area, 1/2 base times height. 1/2 base times height. The area is 1/2. The base is 16 times the height, which is 12. And that is going to be 6 times 16, which is, 8 times 12, or 6 times 16, which is 96. Now we're going to have two special cases of triangles. If we have an equilateral triangle. If you have an equilateral triangle, we know all sides are equal. Each angle is equal to 60 degrees. If I were to draw the altitude or the height down, that splits that equilateral triangle into two congruent pieces. So this is 30. That altitude bisects the base. So that is a over 2. That is the side of A over 2. So to find the height, because the area is 1/2 base times height. Well, I found that the base is the whole segment of A. Now I need to find the height, or the altitude. Well, let's just look at this 30, 60, 90 triangle. I know the side opposite the 30-degree angle is 1/2 of A. The side opposite the 60 is the side opposite the 30, or the shorter leg. The longer leg is the shorter leg times √3. So A √3 over 2. So that's the height. So that's my height. Okay, so let's look at that. That's like saying 1/2 times A, this A right there, times √3 over 2. A times A is A squared. 1 times 3 is √3. 2 times 2 is 4. So the formula for an equilateral triangle, if you choose to remember it, is A squared √3 over 4. Now again, because when you have an equilateral triangle, if you split that up, you're going to easily have a 30, 60, 90 triangle. That's a real quick way to derive the formula. Okay, so the formula, again, was the side squared times √3 over 4. So the area, I have 8 squared times √3 over 4. A squared is 64 times √3 over 4. So area, 64 over 4, that's 16 √3. Again, if you don't want to memorize the formula, it's just going to be a quick deriving of the formula. Okay? When you drop your altitude, you split this into a 30, 60, 90 triangle. This side is 4. This side is 4 √3. So area is 1/2 the base, which is 8, times the height, which is 4 √3. 1/2 times 8 is 4. So I have 4 times 4 √3. 4 times 4 is 16 √3. So what I did there, again, I just showed you both ways to find the area of an equilateral triangle. You can choose to remember the formula, or you can just derive it quickly on a test or a quiz. Now, a special formula that we are going to go over, and this is often something that students forget on a quiz or a test. I go through the formula, we do problems, and then they forget to memorize this formula for the test. If you are given all 3 sides of a triangle, there is a special formula called Heron's formula, where the area is the square root of S times S minus A times S minus B times S minus C, where S is called the semi-perimeter. Now, semi-perimeter is easy to remember. If you remember the name of that, semi, half the perimeter. So you add all the sides together, divide by 2. So first thing you do is you find S. S is 1/2 of 5 plus 6 plus 10. So S is going to be 1/2 of 21, which is 10.5. Now it's just a matter of plugging and chugging into the formula, guys. And it's just memorizing the formula. If you get this one wrong, it's because you didn't memorize the formula. And I'm telling you to memorize the formula. So memorize the formula. 10.5 S times S minus one of the sides times S minus another side times S minus the third side. Okay, so it's just a matter of plugging in your calculator. When you plug all that in your calculator, do all of this multiplication first, then take the square root of it, and you get 11.4 square units. Last example, a rhombus. Remember, a rhombus has all four sides congruent. And I'm going to derive the formula because you know I've been liking to derive the formula. It's important for you guys to see where the formulas come from also. So a rhombus, all four sides are equal. Remember, since it's also a parallelogram, the diagonals bisect each other. But also a property of a rhombus is the diagonals are perpendicular. So we have two triangles. Triangle ADC is congruent to triangle CBA. So if I find the area of one of those triangles, so if I find the area of that triangle, and I cut it and I multiply it by 2, then we're going to have the area of the whole rhombus. So the area of triangle ADC. Okay, so let's call this red diagonal. Let's call that diagonal 1. Let's call the blue diagonal diagonal 2. Since the diagonals of a parallelogram bisect each other, this is 1/2 of diagonal 2. And those subscripts are just a different way of naming diagonals. It doesn't mean I square it. Okay, so triangle ABC. The formula for area of a triangle is 1/2. The base of that triangle, well, that base of that triangle is diagonal 1. The height of that triangle is 1/2 of diagonal 2. So if you take and you multiply the numbers together, you get 1/4 of diagonal 1 times diagonal 2. Now that's just half of it. That's just triangle ADC. Since the triangles, the whole rhombus, is 2 of those, you multiply that formula by 2. 2 times 1/4, well, that's 1/2. Diagonal 1 times diagonal 2. So the area of a rhombus is 1/2 times the product of their diagonals. 1/2 the product of the diagonals. Okay, so now we have a rhombus. The area is 1/2 the product of one of the diagonals times the other diagonal. One diagonal, that whole thing is 6. This whole diagonal is 12. So then you just have to multiply. And when you multiply, you get that it is 36 units. So in this lesson, we derived a lot of formulas. Make sure you know how I derived the formulas that I derived, because I may throw that on a test or a quiz. Sounds like fun stuff to me. All right, there are your lesson questions. I realize it's a lot. I think this was a fairly long lesson, but it is important stuff.